to this lecture. So in this lecture we'll make another function, and that is to calculate the animation speed. So outside this basically walking function, let me just make here that should be named as calculate, and it should be calculate animation speed. Just give the self as a parameter here, and this is basically used to make walking animation speed be in the relation to this Mario X velocity. So just to make that relation here, so firstly we'll just say if X velocity, that is of the Mario, is equal O, that means the animation speed here, so let me say it should be as animation speed. The animation speed here should be, means give here animation speed as something that is 130, and similarly if the velocity is greater than 0, so that means we'll just check this velocity is greater than O, then just make this animation speed to be less than 130. So the factor that will be encountered, and that should be something that is this velocity now should be multiplied by 13 factor. So after this 13 factor, basically this is the relation that will be make our animation, that is for the Mario, and the animation will be walking animation here. So let me just say self.x velocity now should be multiplied by here factor, that is 13. So let me just give it in bracket, and it should be 13. So the next thing, if it is not, that is it must be less than 0. So if it is the condition, then we'll say animation speed should be reduced, and that should be the formula as in self.x velocity, and just multiply it by the factor 13 here, and just multiply it again with -1, because this is basically the for the animation speed, that is when the velocity is less than 0. So just return this animation speed now, and we are good to go. So what you're gonna do now is we'll just define another important function, and that would be jumping function. It will take self, it will take keys, it will take fire group. It should be fire group. So this function will be called when the Mario is in the jump state basically. So let's define this function, that would be self.allow jump should be false at first, and now just define the frame index. So the frame index would be somewhere from 4 to 6. Let me say 4, and self.gravity here, just give the gravity as in c dot, it should be c dot, and just jump gravity. And now next thing what you can do after this is just calculate the velocity and assigned is something that is with this gravity now. So basically this field that is in this X, there should be walking, so we didn't encounter any gravity while walking, but while jumping, that is in the Y direction, we should make encounter of the gravity and take it into account. So let's say that is self.y velocity now should be increased by this gravity. So after that, let's check if it is allowed to fire the or throw the fireballs. So from this function, that is check to allow fireballs, and just give the keys here. So after that, we'll just check for the bunch of velocity condition here to assign this gravity and assign the fall here. So if self dot y velocity, because we are dealing with this y direction, that is because we are dealing with this jumping. So we'll be restricted to use this only this y direction, and if it is greater than 0, and self dot y, and it should be velocity again, that is basically less than the max velocity, that is max y velocity. Then what you're gonna do is we'll just get that self gravity to be this defined gravity, that is from here, that should be c dot gravity here. And next thing what you can do is we'll just assign this state to be the fall state now. So this should be basically our one condition, that is the main condition in order to check if it is a fall or not. So now we'll check for the key bindings, that is for these keystrokes. So we'll say if the keys, and just give the tools dot key binding, and I'll say here that is the left first. And if it is the left, then what you can do is we'll check for another condition here, that is self dot x velocity, that is basically for the movement, is if greater than the maximum of moment of velocity. So that should be if it is greater than maximum, and it should be into -1 to check for this y here. Basically for the left, this is for left, and this is for basically -1 is to check for the opposite of maximum velocity. Then we'll say self dot x should be now, that is the velocity at the x component velocity should be softened with this acceleration, that is, let me just give here x acceleration, that should be somewhere here, x acceleration. So after that what we can do is we'll just check for the right now. So right key bindings can be copied as left here, and instead of left, let me just put here right, and let's get here. So here too we'll just check for the condition, that is the self velocity for the x, and this is basically for the right. So you want to be just subtracting with the -1 here, that is multiplied, and just checking for the basically the max velocity. Rather what we can do in this right is just checking for the less velocity here. If it is less than that of maximum velocity of x component, then what you can do is just assign that x velocity, and it's to be added here because we are moving in this right direction. So left direction have this reduction in the acceleration, that means there should be reduction in this velocity even while moving in left, but in the right there should be the fast movement, and we'll see that while running the game. So I'll say there should be the movement with this x acceleration. So next thing what we can check is for the jump. So I'll say if not, keys, and just grab this tools binding here, key binding, and just pass a key here, that should be jump. Then in that case what you're gonna do is we'll say this gravity should be assigned as in this predefined gravity in the jump case, and there should be obviously the fall here. After you jump, there should be the condition for this fall. So it's time to set the action basically for this key binding, which is basically the action. Let's set it as tools first, check for the key bindings, and if it is action here. So if it is action, what you can do is we'll check if we are allowed to set a fire. That means we'll say if self.fire is available, and if it also that is allow firewall is also even true, in this case you have to shoot the firewall. and you have to just give this fire group, which is basically the group of a fire, and that can be the assets basically. So we have completed with our this jumping function. So next function which is important will be falling function. So this falling will take obviously our keys and fire groups, and just let me assign as a fire group here. And this falling is called when the Mario is in the fall state. So first thing what you can do is we'll obviously check for the fireball if it is allowed or not. So we'll say just pass the key here. So next thing we'll say self dot y velocity, because we are falling. So we'll say y velocity is less than c max y velocity. So it is the condition. So let me say it should be c max y velocity, this one. And if it is the case, you have to just add this gravity to your velocity. That means the movement should be added to the acceleration because you are moving downward. So just add this gravity to this velocity, that is y velocity, and that should be self dot gravity here. So just add it. Now the next thing what you can do is you can just check now for the key bindings, and the key bindings starts from left right action. So let me say if and keys. So just let me give a key and tools first, and just key bindings, and let me say if it is left, if the action is left, then what you're gonna do is we'll check for the condition here, that is the same condition that we did in the case of the jumping. So that would be, we'll just check for the x velocity, and if the x velocity is greater, that is in the case of left, is greater than the max x level, and just give it a multiply with a -1, and then in that case we have to smoothen our speed through just decreasing by the acceleration here. That means just reduce our velocity in x with this self dot, and that should be x acceleration. So what is it's saying is, if you are falling and if you are just having this key pressed as in left, just move left, and in that case if it is basically retarding, here is a retardation, and if it is a retardation you have to just use this deceleration here. So that means if you have a retardation here, just use deceleration. So deceleration means minus of acceleration. So next thing we'll check again for the right here. So basically you could have guessed that in the case of a right there should be the acceleration here. I'll say right, and I'll check again for this self dot x velocity is less than in this case, so that should be max velocity. Then just make the smooth movement of our Mario with an increment with this acceleration, that is just add it with this self dot, let me just give dot and x acceleration. So this should be for the right key movement or right action, and if the key binding is now action, let me say if keys, and just give the tools here and key bindings obviously, and if it is now action, if it is action, what you can do, you can check for the fire, if you are allowed to just hit the fire. That means if this is a fire and if you are allowed to just hit that fireball, then just shoot that fireball. Just call this shoot fireball function and just give this fire group here. So this fire group is same as a group that is of this Pygame module that is maintained as a sprite here. And basically we have completed our falling function. Now it's time to create another function, and that would be something like jumping to death. Let's see if we can just create it, that is from this name jumping to death, and it will just get this object, that is current object, which is Mario. So this function will be called when the Mario is in death jump state. So we'll just call from the timer here. So if the death timer here, and this death timer was initialized at the beginning, so if the death timer is 0, that means just get this death timer should be current time here. This should be obviously current time, and next thing should be current time. Next thing what you can do after this is elif. We'll check the next condition, that is if the death timer is not equal to 0. So we'll say if current time and just subtract with this death timer, and let me say if it is greater than maybe 200, maybe 300 to 500. Okay, we'll stick to 500. Then just increase this velocity of the rect. So this rect is basically in having in y here. Just in this rect we'll just assign this velocity here. So this velocity, and in this velocity of y, you should just increase or uniformly increase through that gravity. So that should be y velocity should be increased now with this gravity, and you are good to go with this jumping to death function. Now it's time to define some of the important function, that is start death jump, and similarly changing from the big to small and small to big size of our Mario. So that will be covered in the next lectures. See you in the next.